This is the Math 2 and Honors Math 2, Unit 7 final review. So now we're on number 39. We have our right triangle here with 5, 12, and 13. We need to go through and figure out if we have true and false statements. So it's going to be manipulating the trig a little bit, maybe a little Pythagorean theorem as we go through, but we can still find what we need. Let's see how far we can get with just looking at it, and we may need to write some things down to start comparing. Let's start with sine of f. Sine of f says 12 over 13. Sine is opposite over hypotenuse. Let's write that there, just so we have our reminder. Sine is opposite over hypotenuse. 12 over 13 looks good to me. Tangent of g is 12 over 5. Well, tangent would be opposite over adjacent. That appears to be 5 over 12. That is false. Should be 5 over 12. Cosine of f is equal to sine of g. Cosine of f is adjacent over hypotenuse. Sine of g is opposite over hypotenuse, which is 5 over 13. They match, both 5 over 13. Good enough. Sine of f, cosine of f. Well, I know cosine of f is 5 over 13. Sine of f is 12 over 13. These do not match, so that is not true. hg equals 13 sine g. That looks like one they're trying to solve. So let's start. What if I just wrote sine of g? Sine of g is opposite over hypotenuse. Well, I wrote 5 over 13 earlier, but it looks like I could write hf over 13. If I did that, it becomes 13 times sine g equals hf, which is not what we're looking for. It does not match. hg, we would actually, looks like cosine of g would work for that, so that's false. 5 squared plus 13 squared equals 12 squared is false. That looks like Pythagorean theorem, but the longest side needs to be by itself, the hypotenuse. 13f equals, or 13 cosine f equals hf. So I'm going to write cosine f. 13 is my hypotenuse, but if it's cosine f, hf is my adjacent, which becomes 13 cosine f equals hf. Looks like it matches, so that is true. And last, cosine of g equals 12 over 13. We found, did we find cosine g yet? We did not. Cosine of g is 12 over 13. That is true. Okay, now for number 40, we have similar triangles, so I'm going to fill values in first so I can match them up with sides. 4 to 8, those are corresponding sides. That means this would be 6, and this would be 10 because of a scale factor of 2. I'm doubling the sides. Now, that's the side ratios. They're proportional, but I also know angles are congruent. That also means if I'm looking at trig ratios of congruent angles, they will also hold up. So for example, B and V are corresponding angles. See, they're both the middle letter. So that means the ratio of their opposite to hypotenuse will be the same. For example, 3 over 5 is the same as 6 over 10. So they're both 3/5, so they're equal, so that's true. Cosine of V is 8 over 10. Well, I changed it over, changed the scale, and that worked, so that is equal. That is true. Tangent of t is greater than tangent of c. Well, the best way to do that is just write the values in. Tangent of t is 8 over 6. Tangent of c was 4 over 3. 8 over 6 is 4/3. They are equal. That is false. It is not greater than. Tangent of v is equal to tangent of b. So tangent of v would be 6 over 8. Tangent of b would be 3 over 4. Those are equal. That is true. Tu equals 10 times sine v. I'm going to write sine v equals Tu, which is opposite side, over 10. This, as I solve it, is 10 times sine v equals Tu. Looks like a match, so that is true. And then last, sine of b equals cosine of c. Sine of b was 3 over 5. Cosine of c was 3 over 5, and that is true as well. Okay, on to 41. This will be solving with trig. I have an opposite and an adjacent. I have no hypotenuse, so that'll be tangent of 40 equals x over 30. I multiply over the denominator. 30 times tangent 40 equals x. I go to my calculator, make sure it is in degree mode, and you know how to use it correctly. I do 30 times tangent 40, and to the nearest tenth, I get that x is about 25.2. If you're not sure how to type the trig ratios into the calculator, I do have a video made that explains how to use different calculators, including your phone. I would check that out just to make sure you're typing them in correctly. For next one, I have an opposite and a hypotenuse. So that'll be sine of 53 equals x over 17. I multiply over the denominator. And now that's going to be 17 times sine of 53. Comes out to be about 13.57. We're going to make that into 13.6. For 42, we need to find the values in our calculator. They say round the trig values to the nearest 10,000th. So if we went tens, hundreds, thousands, 10,000s, just means 4 decimal places. And the angle to the nearest whole number. So this is going to be using our calculator for the ratios and the inverse ratio. So I'll even bring my calculator in here. Sine of 39 is 0.6293. Cosine of 39 is 0.7771. Sine of 51, 0.7771. And cosine of 51 is 0.6293. What I noticed there, these two match. Now 31 and 59 are relevant because they are complementary angles. These would be angles in a right triangle. So the sine of one angle is equal to cosine of the other one. Pattern we have. Now this is saying we're going to use sine inverse because we need to figure out what angle gets us that ratio. So I'm going to go second sine, make that sine inverse. You might have shift or function depending on your calculator, and then do 0.3907. Gives me 23 degrees. Same thing with cosine. Gives me 67 degrees. Sine again, 0.9205, 67 degrees, and cosine, 23 degrees. Again, they match. That's that relationship between sine and cosine. The sine of one angle is equal to the cosine of its complement, the other angle that would be in the right triangle with it. Okay, we take that further. Sine of 47 is this value. Find the angle measure of b in degrees if cosine of b was 0.713. It matches sine of that angle. Cosine of the other one, we'll go 90 minus 47 gives us 43. It should be 43 degrees because we'd have a 90, a 47, and a 43. On to number 43. Speaking of 43, we need to find an angle. So this is going to still use the trig ratio. We're going to use cosine of x equals 8 over 11. But because I'm solving for an angle, it's going to be cosine inverse of 8 over 11. Be careful how you type this in your calculator. This is a good one to practice. If you're doing a calculator where it has just a single line, you're going to want to get the decimal of 0.7272 and then do cosine inverse of that. And it should come out to be about 43 degrees. You should definitely check to make sure you can use your calculator correctly on that. It's important. Next one is going to be tangent of x equals 8 over 13. That is tangent inverse of 8 over 13 equals x. And this comes out to be about 31.6, so we'll call it 32 degrees. For number 44, we have a kite flying at an angle of elevation of 40 degrees. Find the height of the kite if 53 feet of string is let out. This will be a sine of 40 equals x over 53. 53 times sine 40 equals x. And x comes out to be about 34 feet. For number 45, the height of the ramp is 5. The ramp is 10 meters away. How long must it be? Not a trig problem. We're doing all this trig, and this one sneaks in. This is the Pythagorean theorem. X squared equals 5 squared plus 10 squared. We get 25 plus 100 x squared equals 125, which is the square root of 125. They want it to the nearest meter, so it's not a simplified radical. It's just taking the square root of 125, getting it to a decimal, which is about 11.18. Nearest meter be 11 meters. For our last set here, we have our special right triangles, our 45, 45, 90, our 30, 60, 90. For 45, 45, 90, you multiply the leg by root 2 to get the hypotenuse. You make it bigger, so you multiply. To go smaller, you divide by root 2. So this will be B and C. We'll do those two first. On B, again, 45, 45, 90, I want to make the hypotenuse, so I multiply V, or 5, by root 2, so 5 root 2. And it's also an isosceles triangle, so these two are the same, so W is 5. For C, I'm at the hypotenuse and I want the leg. I want to make it smaller. I'm not going to multiply it to make it smaller. I'm going to divide 16 divided by root 2. Now we can't leave the radical in the denominator, so we do what we call rationalize in the denominator, and I get 16 root 2 over 2, which becomes 8 root 2. So that'll be my answer for R and my answer for S. Now the 30, 60, 90 always goes off the short leg. I'm going to double the short leg to get the hypotenuse, and I'm going to multiply the short leg by root 3 to get the longer leg. And remember, the short leg is the one always opposite the 30 degrees. So it's really figure out where you are, where you want to get to, and you have to usually use that shorter leg to get to it. So in A, this is the hypotenuse. To get to the shorter leg, I'm going to divide by 2. I want to make it smaller, so that is 5 root 3. Now from here, I want to go to the longer leg. That's going to be 5 root 3 times root 3. Well, the square root of 3 times the square root of 3 is the square root of 9, which is just 3. So it all comes out to eventually be 15. Our last one down here, D, I'm at the longer leg. I have to go to T first. To get there, I divide by root 3. Well, 9 root 3 divided by root 3 is just as factoring them out. So T becomes 9. From T to U, I multiply by 2, short leg to long leg, so it'll be 18.